Alright, sorry for that silence there, that kind of blew me away. I certainly wasn't expecting that. But I shouldn't get carried away because that is by no means an exhaustive test. It's just like a basic run through of all the opcodes. So there could very well be, and probably is, still a lot of errors in it. But yeah, that is an excellent start. So the next step is to implement the serial hardware, because what we're going to do is we're going to load in like this, although I'm going to have to clean up the UI and everything a little bit. But yeah, to load in Basic using the bootloader that you can get on the Altair clone site, and then we're going to stream the code from the serial port through the bootloader into the memory and let it run it. So it's basically going to act as though it's being loaded from a serial device, from like a teletype or something like that. And we'll see if we can get Basic to run. Right, so I'm going to be getting into territory now that I'm a little bit more uncomfortable with, sort of hardware, serial ports, things like that. But we'll give it a go. First of all, we're going to use this text box as the output and input window. It's not ideal, but it's quick and easy for now. So I'm basically going to switch this to read only. And I'm going to attach key press event to it. There we go. Now, to figure out how to use this serial port thing, I've come across this PDF for the basic SIO serial card, and that's what we'll use. There's no interrupts or anything like that we need to worry about for now. So from the look of this, it communicates via an input port and an output port, but the input port is split into two, and there appears to be like port 0, which is for status, and port 1, which is the actual data, and this is the status byte that's sent back when a request is sent on port 0. So it looks to me like we need to keep data bit 7 and data bit 0 low all the time, because obviously the input and output devices are always going to be ready because they're being emulated. So these are going to be low. Data overflow, framing error and parity error are never going to occur, so we can keep those low. So it just looks like, and this I think we need to keep high all the time, because the transmit buffer is always going to be empty, because we're dealing with this data synchronously, so we don't need to worry about handshaking or anything like that, because as a byte is sent, it's fetched. From what I can tell here, I think when a request is made for the status word, we've just got to determine whether there's any serial data that needs to be sent to the emulator. That being the case, I think bit 5 needs to be high. Yeah, I think no data available, we just send bit 1, which would be a 2, and if data is available, we send a bit 5. So 34. So 2 for no data available, 34 for data available. Okay. One thing I need to do here is e handled equals true, and that will stop the sound from going. You know, when you press return in a control that's read only, it makes a ding. That will stop that from happening. What we're going to do is we're going to make form, our main form, implement those interfaces. So it's going to be an I input device, output device. So we're going to need to implement the interface. So request read, so we can switch on port here. Just default there, okay. So case 0, which is the status port, and we'll have case 1, which is the data port. Request write. Okay. So again, okay, so if some data comes in, we basically just need to display it on the text window. This should just be a question of append to the log window, and then we need to convert val into a string, so we can cast it to a char and then to a string, and that should put the output on the text window. Okay, we also need to register, so Altair register input device on port 0 and also on port 1, and register output device on port 1. So if we press a key here, we need to send the key press that we have made to the serial device, but also the serial device is going to be used to send the basic code as well. So we're probably going to need some kind of character buffer. So let's create a character buffer. Okay, then we need a counter. Okay. Now when we read, we need to send back whether the data is available. So that's going to be if the write position is greater than the read position. If so, then a byte is available, and we said 34, and if not, 2. And to read data, now I'm assuming it's not going to attempt to read if there's no data available, but we'll just make sure. So if write position is greater than read position, then we return buffer read position. Okay, we'll call it write serial data, and we need to lock on the buffer just to make sure another thread doesn't access it at the same time. Read serial data. Okay. We're going to need the serial bootloader and also the basic code. So these are available on here. So it's the SIO loader we want. It's the extended basic. There's no actual raw data file, but not to worry, because we can just make one. So if I remember rightly with this, we have 4 bytes for length, 4 bytes for location, and then at the end we have like a check byte or a check CRC or something like that. So it's that data we need there. So we'll copy and paste that into the hex editor, and also that data. And paste that in. I think that is the bootloader. So if we just save that as a binary file, we can just load that into memory directly, into the main folder there. So this is going to be basic loader.bin. Now we're also going to need extended basic image. So it's basic extended basic 4.1. Okay, so we'll save that link. We'll put it in the same place. We'll call it basic.tap. Okay. So now what we're doing is we're going to reset to location 0, and we're loading in, so basic loader.bin. We'll load that into address 0. We're also going to need something to be able to write things to the serial . Okay, we've got an error. Where's the unreachable code? Now I slammed that together really quickly, so I don't expect it to work. Let's see what happens. No, I didn't think so. Oh, did I take out that debug code? I didn't, did I? Yeah, let's get rid of that. I'll just comment it out. I haven't set the front panel switches, which is something you're supposed to do, I think. So let's just take a look at this loader. That's the loader we looked at. Yeah, A13 and A9 need to be on. Altair set switch. And 13, I believe. Very sellotaped together, that is. Oh well. It's making my eyes hurt. Alright, let's see if we get anything now. Nope. Yeah, we're still just jumping around in that loader loop. So I'm reading in the basic loader and then I'm shoving a return instruction in there. That probably isn't doing it any good. Okay, let's try again. Ooh. That's different. Stack overflow. So it is trying to send some data out. Oh, yeah. Look at that. Just one underscore. Okay, let's try again. Memory size. That is exactly what we wanted to see. That means that BASIC has actually run and has started executing. We can't type anything yet, so where are we? We need to send when we press a key. Where have we got to? So e.keychar turn that into a byte. Now let's see if we actually have some basic action. Memory size, okay. Line printer. This is looking good. Oh my god. Okay. Let's do the classic program then. Oops. You can't backspace. You have to do a underscore, if I remember correctly. Oh dear, that doesn't look right, does it? No, there's a definite problem there. Well, the program's running, but that certainly isn't right. Must be some strangeness going on with the instructions somewhere. Just not quite right. So I'm going to need to go through that. But we do have a basic environment running. I'm going to have a scour through the instructions and see if I can fix this. Okay, I found something I think isn't right. So RAL and RAR. It rolls the bits in the A register. It takes the carry bit and puts that at the other end, and then the bit that you shifted off the end goes into the carry register afterwards. So if we rotate right here, so A shifted right by 7 bits will just leave, yeah, this ain't right. We're going to lose the most significant bit, okay? And we're saving the most significant bit there and then putting it in CF. And so that one looks right, but RAR isn't, look. Because we're shifting right, we're going to lose the least significant bit. So this needs to be not shift right by 7 bits, but and 1. That will leave RCF as 1 or 0, depending on whether bit 0 of A is set. Then it will shift it right. It'll put the carry flag into bit 7, and then it will then set the carry flag to whatever bit 0 was. So hopefully that's what's causing it. So let's give it a go. Okay. Oh, that's not right. 20, go to 10. Oh my god. Oh, there we go. That's the one. Yeah, that took some finding. Basically what I was doing, I was just, because nothing else in Basic seemed to be affected, so I went on the hypothesis that whatever instruction was causing the problem was only being executed when you listed the program. So I went through every instruction and put a breakpoint on there, and it was on that roll instruction that the program broke out when I typed list. Now this doesn't mean that it's all working properly by any means. Basic apparently is very forgiving about processes not working properly, so this is by no means a good test. Probably CPM would be a little bit better, but for now I think we're good there. So now we need to set up running one of the programs from the Altair clone site, like Blackjack or Zilch or something like that. Okay, so here we are on Altair clone. Got a bunch of basic programs that we can try here. So I'm going to try Zilch. So I'm going to save that. And we can save that directly into the debug folder there. So let's go into our design. We need to put let's put a load button on. So button, load. Okay, we need a open file dialog. OFD, load, and the directory, initial directory, we'll set to our folder where everything else is. When we double click load, or when we click load I should say, dialog load, show dialog, and we want dialog results. If dialog results equals, okay, then we should just be able to send serial bytes, so write bytes to serial. Okay, so write bytes to serial, and then it's going to be file dot read all bytes, and that's going to be OFD load dot file name. Okay. Memory size. Okay, let's see if we can load in the program. That's looking good. Do you want instructions? No. Number of players, 1. The name of player 1. Yeah. Can I play 2? Yeah, go on then. Okay. Do you want to roll? Yes. So we're going to keep 1 E and F. 4 dice left. Oh, damn it. Okay, Walter's got 1050 ahead of me now. Guess of that. Right, what we got? We've got 3 6s. Okay, so A, E, F. Shall we chance the next 3? God damn it. Not doing well here. I think Walter's going to beat me. Okay. Yep. 1, 2, 3, 4, 5, 6. Oh. Yes. Well, we'll roll again with 6 dice. Definitely. Well, that's pretty bad. Okay, we'll keep D. Yeah, we can roll with 5. Oh, look. B, D, E. Oh, yes. Do you want to roll? No. I'm catching him up now. Lucky git. Okay, that's not very good. Okay, we'll keep B, C, and E. $200 isn't very good. We may as well try for more. We'll keep B. 2 dice. Whoa, whoa, that's lucky. A, B. Yep. Oh God, what a terrible. Okay, A and D. Yeah, go on then. Oh, A, C, and D. Yeah, I think we'll keep that now. Okay, we're ahead now. Don't believe that look he's getting. Ugh. Okay, D and E. Oh, damn it. Okay, I'm only just ahead. I need a good... Oh, look at that. No, we don't want to roll with that. We only need 200 more points. Come on. Yes. B, F, and E. Do you wish to roll? No? You zilched. Yes, I win. Great stuff. Okay, so sorry about all of that being so long, but as you can see, it's a big project, but we managed to get it going. It is a bit messy in this main class. I was really rushing to try and get it to work, but I'm going to play with this now and tidy it up, make it a lot better. Anybody who's interested, I'll put the source on GitHub once I've tidied it up so it's not embarrassing like this is. So anyway, thank you for watching and for bearing with me and through all of that, and I'll see you later. Bye.